Oh boy, I made a thing! Look at that! Let's see what it does. So, we have a power supply, or plug. Plug that into this thing I've jerrigged up to a little USB cable thingy. Plug it into a power supply. Upside down. And away it goes. Wow, look at it go. It is an hourglass. And you can change how fast everything works by this little resistor right here, variable resistor. And now you see it goes much more slowly. Now, of course, this is putting out enough light that the camera is washing out, so you might not be able to see. As one light turns off up here, it turns on down here. Cool. Isn't that amazing? Let's look at how it works. And this is the part where everybody stops because nobody wants to listen to this. But I'm going to talk about it anyways because I spent a day looking at the stupid thing, working out the schematic to figure out how it works. Okay, so we got two halves here. All the logic on this side and the LEDs on this side. LEDs are just LEDs. There's not much to talk about there. This is kind of cool. We have 3 chips worth talking about. We have 2 on the left, 4015s, and on the right, 14069. What are those numbers anyways? They are these chips. 4015s are 2 4-bit shift registers. You chain them together like in this, and you have one 16-bit shift register. What's a shift register? Let's not worry about that right now. Then you have a 4069. That is a hex inverter. Hex is just a fancy way of saying 6. It's saying that it has 6 inverters in it, or 6 NOT gates. So you see, like, you have the letter A here, and then you have the letter A with a line over it. So if a high signal goes into the pin marked A, a low signal comes out of the A with a line over it. If a low signal goes into the A high signal comes out of the A with a line over it. Dig? Okay. So let's start down here. This stupid little circuit is using 2 of those inverters, the A and B inverters. The rest of them, the C, D, E, and F, none of them are used. Seriously, this whole chip here is just using those 2 things. It's a complete waste of time. But what this does is electricity does magic, and you have a clock signal at the end of all of this stuff. That just means it goes from low to high to low to high. It keeps doing this over and over and over. And what speed it goes low to high is controlled by that variable resistor. This thing right here, a little arm on it, that 1 meg thing, that controls how fast this clock signal that this little circuit generates goes. Where does that clock circuit go? Ah, now we get back into the whole shift register thing. Shift registers are great. You have an input. That's awful looking, but an input, and you have a clock signal. I just showed. And I don't know why I'm drawing it like this now. I have no idea what I'm drawing. So this input thing, this will have either a high or a low signal on it. The clock, likewise, will have a high or a low. When the clock goes from a low signal to a high signal, okay, that is when this chip does magic. And if the clock signal stays high, or if the clock signal goes from a high to a low, the chip doesn't do anything. It doesn't care. It only cares about when the clock signal goes from low to high. What happens? Great. When the clock signal goes from low to high, it looks at what is at the input signal. And is it a high signal or a low signal? Whatever it is, it stores it in position 1. Okay, we'll say it's a high signal, right? And then you have, again, I said this was a 16-bit shift register. These 2 things chained together make it one big 16-bit shift register. Okay, great. Now, so we've got a high signal. Let's just call it a 1 for a high, and a 0 for a low. So we got a number 1 in there. Next clock signal comes in that goes from low to high. There's a 0 here. This 1 shifts over, and now there's a 0 in position 1. There's a 1 in position 2. And it just keeps shifting the numbers all the way over from position 1 to position 16. So what happens when you get to position 16 over here? What happens to that 1? It goes away. It just disappears. It's gone. It just gets shifted out. Now, let us look back. And if you count the number of LEDs here, or if you kindly just look at the number here, this one is marked LED 15, this one is marked LED 30. How many LEDs do you think there are on each side? Nope, you're wrong, it's 15. And we have 16 shift registers here, 16-bit shift registers, 16 positions in this thing. We don't use the last one, we don't care about it. So 1 through 15 is all we care about, and signal just keeps shifting in. Where does that signal come from? Oh, excellent question. It comes from a switch. What's the switch? It's this silly thing right here. This tube, this canister. What it is a tilt switch. It is literally just a little can with a ball bearing in it and a couple of pins coming out of it. And when it's flipped upside down, the ball bearing is up here, there's no connection. If it's flipped upside right, the ball bearing has come down, it's touching these two contacts, creating a connection. Power from the battery goes into this switch, and if the ball bearing is such that it's making a connection between these two pins, then electricity will go into the shift register, the first position. Where is that awful drawing? The first position of the shift register. But if it's in such a way, if it's upside down, so the ball's down here, right, and the contacts are up here, then instead of a 1, a 0 goes in there, because there is this little pull down resistor here. So there you go. So depending on if that little tin can if the ball bearing in it is up or down, is what controls what value goes into the shift register. So we have a 16 position shift register, but we only care about the first 15 of those 16 positions. We have a tilt switch controlling what's going into it, and the clock circuit that triggers how often the shift register shifts its values over by 1 is controlled by this clock circuit, the frequency of which is controlled by this little variable resistor. Right, so now we see how this works, right? We just put the two things together like so. We turn it on, and if it shifts a 1 in, it starts filling up the LEDs here. If I tip it upside down, it's a 0, and the LEDs start disappearing up here. But then they start appearing down here. How does that happen? Oh, that's the best part. That is a wonderful little tricky thing. So we have your 16-bit shift register, okay? And I say 16-bit, you can call it 16 position or whatever. It does not matter. And you've got all these outputs, right? From output 1 to output 16. Oh, I should have drawn it down here. Output 16, but it doesn't matter because we don't care about it. We only care about up through output 15. Great. If there is a number 1 here on position 1, the signal is high. So there is voltage coming out of this pin, and that voltage will go out of the pin into an LED, and then through a resistor to limit the current, and then to ground, and the LED will turn on. But if this is a 0 on the bottom half, or on the other side of for whatever position I pointed to earlier, go to the other one now. On the other side there is a, let's call it VCC. This is the voltage coming in. This is the power coming in through a resistor, through an LED and connecting also into pin 1. So do you see what happens here? When pin 1 is set at a high value, electricity goes up, out through this diode into ground, turning this LED on. It doesn't go backwards through this LED. LEDs have electricity only goes one way. So electricity does not go this way. It just goes up through here to ground. Cool? But if this is a 0, that means it's connected here internally down to ground. So electricity can flow through here, through this diode to ground. And again, there's no power over here that would go through this way, backwards through an LED. So this LED never turns on. So when this is a 0, this LED turns on. When this is a 1, this LED turns on, and they're never going to be on at the same time. Do that for all 15 positions we care about. And now if it's a 1, the LED on this side is on. If it's a 0, the LED on this side is on. And that only took 10 minutes to explain. And that's as good as it's going to get. Now, I'll show you why this circuit, or one small problem, one small oddity with this circuit. Plug it in. Let's speed it up because... Okay, now watch this. I'm just going to tap it. Come on. See if I can get it to... I'll flip it upside down for just a brief moment and turn it back. And you see the sequence gets a little out of order now. If I slow it down a little bit, you get to see one interesting thing, which is the LED that's on up here, the corresponding, or the mirror LED down here is going to be off. Come on. There we go. So watch this LED. You can see a mirror LED, or no, I guess just an opposite LED is going to be off down here. There's your shift register. These 15 shift registers, or these 14 are on, and that one is off. Now it's on. Now all 15 shift registers in here are on. Flip it upside down. Now they're starting to turn off as the zeros start flowing through the shift register. And that is how this, whatever it is, hourglass. Have I said that yet? Probably not. That is how the hourglass works. Kind of cool.